Hello, math champions. So today in this video, we're going to talk about one more circle theorem. And this theorem states the opposite angles of a cyclic quadrilaterals are supplementary. Now here, before you understand this theorem, you have to understand few terms here called cyclic quadrilateral. What is a cyclic quadrilateral? It's a quadrilateral which is there inside a circle. That means a quadrilateral whose vertices are standing or vertices are on the circumference of a circle. So if we are having a quadrilateral like this, okay, where all the vertices are of this quadrilateral are on the circumference of the circle, such a quadrilateral is called cyclic quadrilateral. And the next term that you have to learn about is called supplementary. Supplementary means the angles whose sum addition is 180 degree. Is 180 degree. So such angles are called supplementary. Okay. When after you've understood these two terms, let's get into the proof of this theorem. Okay. So after we have read this theorem, we know that we need a cyclic quadrilateral. That means a quadrilateral inside a circle. So this is our center O, and we have a quadrilateral. Let's name it A, B, C, D. Let's name that. And they also say it's opposite angles. Means this is one angle. Let's say this is X degree. And the opposite angle means opposite to this A vertex is a C vertex. Let's name that angle, give a degree for that as Y degree. Okay. So these are the two opposite angles of a cyclic quadrilateral. This is what is given to us. Now, what is it we have to prove? We have to prove they are supplementary. That means these opposite angles, X and Y, the sum of it, that means X plus Y is going to be 180 degree. This is what we have to prove. Okay, let's write down what is given. As we know, the various different steps. The first step is a cyclic quadrilateral. Okay, cyclic quadrilateral. That is what is given. Cyclic quadrilateral. And ABCD is given to us. And O is a center. So basically it's a circle. These are things we know. And what is it that we have to prove? We have to prove that this angle, opposite angles, that is X plus Y is equal to 180 degree. That is what we have to prove. And next step is, right? We just with this, we cannot do much. Of course, we know one quality of a quadrilateral, one of the properties, one of the characteristics of a quadrilateral is if we add all these angles, then it is equal to 360 degree. That we know. But however, that particular thing is not going to be of much help for us. So what else we can do? What else we can do? This is where we do something called construction. Construction is anything that we do in this diagram which is not given in the theorem statement. Theorem statement has a cyclic quadrilateral, that means a circle and a quadrilateral, and has opposite angles. Yeah. But then for construction, what we are going to do, just like other circle theorems, we are going to use this fact that two radius we can do, right? So other two vertices we can join so that OB and OD are radii. Correct? So connect O and B, that is, and also connect O and D. What happens? So that OB is equal to OD, that's a radii. Okay. So that is equal, we know that. Okay. Because we have known that, next let's go to the proof. For this proof, we are going to use the existing theorems knowledge. Now, because angle DCB is equal to Y, okay, angle DCB is equal to Y degree, right? And we also know that angle DAB is equal to X degree. We know that, right? If DCB is Y, that means it is subtended by this arc called DB. Okay. It's subtended by the arc called DB at the circumference. And we know the theorem that if an arc is subtending an angle of y at the circumference, then at the center it is going to be 2y. Right? So we can say angle DOB will be 2y. We know it is double. So for that we can write angles at center is twice the angle at circumference. So this is a theorem we know. We write that. Similarly, if DAB is x, then what is that arc? The arc is this side, the major arc DB. So what happens? This angle will become 2x because it is, for clear understanding, let me draw it in different colors maybe. That will help you to figure out. So this arc is subtending an angle of x at the circumference, means at the center it will subtend an angle of 2x. So I can write that angle again, the other reflex angle DOB will be 2x. Reflex angle DOB, right? So this is the two things we know. And now what we can do, angle DOB plus the reflex angle DOB. These two, when we add together, we know it's a complete angle. Complete angle means it is going to be 360 degree. That means 2y plus 2x is equal to 360 degree. That means if I want to divide the entire thing by 2, if I divide the 2 for everything, then it becomes y plus x is equal to 180 degree. Or in other words, x plus y is equal to 180 degree. And that is what we wanted to prove. And that is why it's very important to write these steps like given, to prove, construction, proof. Because once we have arrived at a certain thing, you will know that you have arrived because you have defined the destination. The destination is this part here that we are mentioning here. So in the process of proving, what will happen? If you have reached a destination, you will come to know and you can stop your proof, right? As do we need to have any other reasons here? No, we can say it's a complete angle. Complete angle. That is 360 degree. And here there's no reason, I'm just going to divide them. I'm going to divide them and thereby I'm getting it. There's no more reasons required and hence we have proved it. And it's as simple as that. As simple as that. I hope you've understood how the arc is subtending that angle and everything. I hope you've understood that. We are going to use that theorem. If you have not understood that theorem's proof, maybe you have to go back in my channel to view that video where we have figured out that the angle at the center, this angle is going to be twice the angle at the circumference. Okay, I hope you have enjoyed this proving and as well as you're enjoying geometry learning as well. See you in the next video. Bye-bye.